But we will consider these quantities. Wow, Amartya, great job.
Sorry, sir, I forgot.
Okay. So till this point, you don't have to see the recording also. No, this is just basic. Okay. So since moment of inertia is a tensor quantity, we know that. But since tensor quantities are not in our portions, we will consider this scalar until and unless it is mentioned. For example, if they ask you specifically, moment of inertia is a scalar, vector, tensor, none of these, then what we should take? Tensor. If tension is not mentioned, then what we should take? Scalar. Got it? Got it, guys? All of you are okay with this?
Yes.
Yes.
Okay. All right. Now, there will be different types of vectors. Of course, equal vectors. When I say A vector is equal to B vector, it means that magnitude wise also they are equal and direction wise also they are equal. No problem. So a vector is represented by an arrow like this. This is called as the tail and this is the head. The head actually shows you the direction, whereas the distance from tail to head shows you the magnitude. So if I call this as A vector and this is my B vector, can you tell me that which is having a greater magnitude? Satvik, can you tell me which is having a greater magnitude? B, of course. Yes, B is having a greater magnitude. No problem. Now there are different types of vectors which we will define. Equal vectors means when both of them are equal, A vector is equal to B vector. Then the second will be parallel vectors when both of them are having same direction but not equal magnitude. Got it? Parallel. Any problem, guys, in this? Okay. Then the other one will be anti-parallel vector. Anti-parallel means magnitude can be different, but the direction is 180-degree with one another. Any problem? Any problem, guys?
No, sir.
Collinear vector, which are in the same straight line. Okay. All right. Then zero vector or null vector, whose magnitude is equal to 0 and it has got no direction. No real sense of direction. No problem. Or you can say sometimes arbitrary direction. We don't know. Okay. Now there are certain properties of null vector that you should remember. What are the properties? A vector plus minus AB vector will be equal to null vector. A vector plus minus A vector will be equal to null vector. Understood this? Okay. Did you get it, guys? Okay.
Yes, sir.
If A vector plus B vector is equal to null vector, it means A vector is equal to minus B vector. Obviously, null vector into A vector will be equal to null vector. Correct? Yes.
Yes, sir.
Anything added to a null vector will be equal to the same vector. Any problem?
I can't understand this part, sir.
So, okay. 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 Suppose this is, oh, I'm sorry. What did I write? Just check this. A vector plus B vector is equal to null vector. That means A vector is equal to minus B vector. Okay?
Yes, sir. Got it.
Got it? Ria got
Yes,
it?
sir.
Clear, no? A vector plus B vector
Sir.
is equal to Elvin, any doubt?
No, sir.
Okay. A vector plus B vector is equal to null vector. That means A vector is equal to minus B vector. A vector plus minus A vector is equal to null vector. Anything multiplied with null vector is null vector. Anything added to null vector, it gives you the same vector. No problem?
Yes, sir.
Okay. So these are just some properties of null vector. Now next part is unit vector. What is unit vector, guys? Suppose you want to go from one point to another point. Let me just name the points. Let's say you are at some point A and you want to go to some point B. All right. How do you go from A to B? That's the question. How do you go from A to B? So there is your friend who wants to call you and ask you that how do I come to your place, or you're calling your friend, how do I come to your place? How do you talk about their directions? So what we do, we define a three-dimensional Cartesian coordinate system. So now we are just considering two. So let's say A is at the origin, goes like this. Okay, then he says, okay, if you join the two lines, this will be called as position vector. All right, so the vector of showing the position of a body from the origin is called as what? Position vector. Clear with the position vector? Which means it has got some magnitude, no? Let's call this as, for the time being, let's call this as B vector. So B vector will be having some magnitude like B bar times B cap. Now B cap is telling you the direction and B is the magnitude of this vector. Clear with this? Easy, not done it many a times, right? Thousands of times, I think. Satvik, clear?
Yes, sir.
Okay. All right. Now there are different forms of vector. Which part, Ria? Okay. The null vector part, is it? Unit vector? Okay. Unit vector means actually direction. Unit vector means what? Direction. So if I have to go from point A to point B, then how should I go? Because this much length, let us say I am at this point A, and I want to go to point B. Let us say this is 5 kilometers away or 500 meters away, something like this. Okay. Now 500 meters is this point also, 500 meters is this point also. If I draw a circle on a 500-meter radius, every point on that circle will be 500 meters away, isn't it? Yes. So how do I define this? So I define a specific direction. And how do I define specific direction? I join the initial point and the final point with a straight line. And I say that this straight line, the name of this straight line, the direction of this straight line will be called as B cap. Just like how we put the name of the roads, no? Mahatma Gandhi Road, this road, that road. Come straight to 5 kilometers on the Mahatma Gandhi Road, like that we say, right? Isn't it? So this name of the road is B cap, which is called as unit vector. Okay. So you are saying go up to 500 meters. Now 500 meters is the magnitude of B vector on B cap. So any point on this line will be called as B cap, and anything in this direction will be called as minus B cap, because this is showing you the direction only. So unit vector is nothing but a vector B can be written as magnitude of B times direction of B. So now this unit vector or B cap can be written as B vector divided by its magnitude. Any problem, guys? Understood this? Yes. Ria, is this clear now? Satvik, clear? No problem. Unit vector ki kahani is clear?
Yes, sir. So clear.
Okay. All right. Now what we do is to remove all. Yes.
So should I note it down or
See,
just listen?
you'll be
Or
having the recording. You'll be having the recording, and then you'll be also having short notes. Plus, you'll be getting the book also as well, right? I don't think
Okay,
you
sir.
need to note it down. Just try understanding in the class, okay?
Okay, fine, sir.
Put your entire focus on understanding. If you have got anything that you're getting stuck at, then you let me know. Okay. All right. Now, next thing. What we have done is we have defined three mutually perpendicular directions like this. And we have defined this as axis. So we call this x-axis. We call this y-axis, and we call this z-axis. This is plus z. This is, of course, minus z. This is plus y. This is, of course, minus y. And this is plus x, and this is minus x. Now, anything that you can think of will have three coordinates, x, y, and z, whether positive or negative, doesn't matter, but it is going to have three coordinates. So what we have defined is that, okay, anything in this positive x direction, we'll call it as I cap. Anything along negative x direction will be called as minus I cap. All right. Anything along positive y direction will be called as j cap. Anything along negative y direction will be called as minus j cap. Anything along positive z direction will be called as k cap. Anything along negative z direction will be called as minus k cap. Understood the sense of unit vector for all these three directions? Any problem, guys? All okay, right?
Yes, sir.
Okay. Can I go ahead then?
Yes, sir.
Yes.
Next is angle between the vectors. Whenever you talk about two vectors and they coincide, okay, the angle between the vectors, how do you define the angle between the vectors? Whenever angle between two vectors is to be taken, we must make sure that either the heads coincide or their tail coincide. Okay? Did you understand? Which means the angle between, if this is A vector and this is B vector, angle between the two vectors is theta. If this is A vector and this is B vector, angle between the two vectors is theta. Did you understand this meaning of angle? Got it, guys?
Yes,
Okay.
sir.
But what if they are coinciding in some other way? Like, for example, if a head coincides with tail, if this is A vector and this is B vector, then the external angle, there are two angles over here. See, if I can draw this, there is an angle which contains both the vectors and there is an external angle. No? There is an external angle. So this external angle is the angle between the vectors. Did you understand it, guys? Is this concept clear to everyone? Did you
Sir,
understand this,
actually,
all of you?
can you tell again, sir?
Yes. When you talk about two vectors and the angle between the two vectors, then either the heads should coincide, the angle between the included angle between the two vectors will be the angle between the vectors, or the tail should coincide. The included angle between the two vectors will be the angle between the two vectors. No problem. But if
Okay, sir.
head is coinciding with the tail, then you have to take the external angle, not the angle which includes both the vectors. The external angle is the angle between the two vectors. Clear now?
Sir.
Okay, you have to take the external angle as theta.
This is the external angle, yes.
Okay, sir, fine.
This is the angle between the two vectors. Got it? For example,
Sir.
if this was the situation, you have got two angles, right? Just tell me this. Okay. This angle is 120 degree. This angle is 60 degree. Can you tell me which angle is the angle between the two vectors A and B?
120 degree.
Exactly. So if the head is coinciding with head, the included angle between is the angle between the vector. If the tail coincides with the tail, this angle will the. But if head coincides with the tail, something like this happens. Then this angle is not the angle between the vector. The other angle, the excluded angle is the angle. Did you understand?
Yes, sir.
Any problem? Ria, Amartya, Elvin, Rishi, anyone?
No, sir.
No problem.
Satvik,
No, sir.
all clear?
Yes, sir.
Okay, can I go ahead then?
Sir,
Yes.
here you can also make it that so the tails meet, right? So you can extend the line downwards and then
Yeah, you can do anything. That's not a problem. If
Yeah.
I extend this line downwards, then this angle is not equal to this angle. No, this angle is still equal to theta, right?
yeah, vertically
So
opposite.
that is why we have taken this angle. No, that is why we have taken this angle. All right. See, angle
Sir.
between the two vectors is going to remain the same. First thing, okay. So generally what we do is we parallelly shift the vectors so that their tail and tail coincides and so that we can see it easily. But if in a diagram they have given you like this, where a head and a tail is coinciding, what I told you, this angle will be theta. If you parallelly shift this guy, think of parallelly shifting it. Okay, so this vector was over here. This vector was over here. If I parallelly shift, this will come over here. What is the angle between the two vectors? This angle, no? And that's equal to this angle only, isn't it? Understood? No? Satvik, is it clear?
Yes, sir.
Clear to everyone? Can I go
Yes, sir.
ahead? Perfect. Okay. Now, most important, a vector can be parallelly shifted. So you can shift this vector parallelly anywhere. Because when you are shifting it parallelly, you are neither changing the magnitude nor you are changing the direction. You can shift it forward, backward, anything. Any parallel movement does not change the vector. Because a vector is made up of two things, magnitude and direction. So head to tail distance should not change and the direction should not change. So if you shift it parallelly, then the vector does not change. Clear with this idea? Now, very important thing, triangle law of vector addition. Triangle law. What does it tell you? It tells you that if there is a vector A such that the head of the first vector coincides with the tail of the second vector, then the resultant is drawn from the tail of the first vector to the head of the second vector. This vector will be R vector, and R vector is equal to A vector plus B vector. Clear with this? Clear with this? No problem. Clear with this, everyone? Okay.
Yes, sir.
Now,
Yes, sir.
this is the case, then what I can say about the angle between the two vectors? The angle between the two vectors is theta. Extended angle, yes. Yes, guys, just now we have discussed, no? Okay. Now, something basic. If there is any vector A that makes an angle theta with any line, it can be broken down into two components. Along this, it will be A cos theta. Perpendicular to this, it will be A sin theta. Yes, we have done this many a times. All of you know this, yes or no?
Yes, sir.
Correct, Satvik?
Yes, sir.
Okay. So now what I can say about this one? I can certainly say that this is going to be equal to, this is going to be equal to B sin theta, and this is going to be equal to B cos theta. Now they will ask you two things, alpha, the angle that the resultant makes, and what is the magnitude of the resultant. I think you all know with the formula, so I don't have to go for any kind of derivation, but if you want, you can find this. This plus this ka square plus this ka square should be equal to r ka square. Yes or no? Pythagoras theorem, guys. This is 90 degree, no? Look at this triangle. A plus B cos theta whole square plus B sin theta whole square should be equal to root over of R, isn't it? Or R square should be equal to this much. So you get what? A square plus 2AB cos theta plus B square cos square theta. This gives you what? B square sin square theta. Of course, if you take B square as common, sin square plus theta, sin square theta plus cos square theta becomes equal to 1. Finally, the value of the resultant comes out to be equal to root over A square plus B square plus 2AB cos theta. Correct? Clear now with this idea? Yes? Clear with this idea?
Yes, sir.
Okay. Satvik, any problem? Pranav, any problem?
Sir, I've never done the derivation. Can you do it once?
Okay. So if you see this triangle, this is the right angle triangle, right?
Yeah, I understood the Pythagoras theorem after that.
So I can write A plus B cos theta ka square plus B sin theta ka square should be equal to R square. See this?
Yeah.
Correct. If I square this, you get what? A square plus B square cos square theta plus 2AB cos theta, right? And this term is going to give you what? B square sin square theta. Now, when you take B square as common from these terms, you get sin square theta plus cos square theta, which is equal to 1. Correct? So you'll be left
Yeah.
with A square plus B square plus 2AB cos theta. Got it? No? Root over. Any problem? Okay. What
No,
about
sir.
the angle? What about the angle alpha? Tan alpha will be equal to what? Tan alpha will be equal to P by B. So it is B sine theta divided by A plus B cos theta. Understood? All of you understood this? Is it okay, guys? Okay, okay, okay. Can I go ahead?
Yes, sir.
Yes, sir.
Okay. Next is next is our parallelogram law of vector addition. What is parallelogram law say? It tells you that if there are two vectors which form two sides of a parallelogram, says that this angle is theta, angle between the vectors of course. So I know one thing, that if I shift them parallelly, over here they're connecting tail to tail, right? So if I shift them parallelly, the parallel shifting of the vector doesn't affect the vector, yes? No problem. So if I shift this vector parallelly such that the head of the first vector coincides with the tail of the second vector, from triangle law I can draw the resultant, which is along the diagonal of the parallelogram. Did you understand? So this will give you the resultant is nothing but extended form of the same triangle law of vector addition. So if I can just rub this off and I can just draw this and write it as B, and I can again write this angle as theta, then I can immediately draw the same diagram. Now, did you understand this, guys? This length is B cos theta, this length is B sine theta. Again, from here also you
So
get
and
the
this
same form.
triangle of addition, but parallelogram is like little confusing.
It's just another way of saying the same thing. It says that if there are two vectors which form a parallelogram or two sides of a parallelogram, the direction of the resultant will be along the diagonal of this parallelogram. All right. So look at this diagram first. Then I'm saying this is A vector and this is B vector. I'm just saying that, okay, if this is A vector and this was your B vector, can I shift this B vector parallelly like this? Yes. If I shift it, can I move it like this? Yes. I'm not changing the vector, no. Remember, parallel shifting of the vector doesn't affect the vector, correct? Did you get this?
Yes, sir.
Now, this is a situation where first vector and second vector are like such a way that the head of the first vector coincides with the tail of the second vector. So the resultant will be drawn from the tail of the first vector to the head of the second vector. If I just show you the previous diagram, this is how the vector was, isn't it? Is it not the
Yes.
diagonal of the parallelogram? This is the parallelogram now, yes? This whole thing
Yes, sir.
is the diagonal. It's just another way of seeing the triangles law. Got it? Got it, everyone?
Yes, sir.
Okay. Next is polygon law of vector addition. Polygon law of vector addition. So if you have got n number of vectors such that they make n sided of n sides of a polygon. Suppose this is A vector, this is B vector, this is C vector, all right, and this is D vector. Then you can say, or so what will be the resultant? So basically, if you see the first vector, A vector, is such a way that its head is coinciding with the tail of B vector. So if you draw the first resultant, it will be like this. Correct? No? Yes. Did you understand? I can remove these two vectors. I can remove these two vectors now. I can say that I can remove these two vectors and I can write directly this resultant vector as what? A vector plus B vector. Correct? Now again, you have a situation wherein there are two vectors such that the first vector head collides with the tail of the second vector, right? So resultant will be from tail of the first vector to the resultant of the second vector. And this will give you A vector plus B vector plus C vector. Any problem? Did you understand this? Is just all extension of triangle law. Got it? Okay. Which means if you have got n number of vectors, A, B, C, D, E, something like this. A, B, C, D, E. All these are vectors. And they ask you what is the net resultant. The net resultant will be drawn from the tail of the first to the head of the last vector. This will give you the net resultant, which is A vector plus B vector plus C vector plus D vector plus E vector. Did you all understand this?
Yes, sir.
Clear, Satvik, clear?
Sir, if they ask the angle between the vector, like the resultant vector, and
They won't.
they won't. Okay.
It will be just like, they will put it on a hexagon or a triangle or a parallelogram, something like this they will do.
Okay.
Is it clear?
So is there a formula for this, or do we just individually add it?
Directly you individually add it. Actually, you should
Okay.
remember it as a result.
Okay.
Okay, you can just remember this as a result. Okay.
Yes, sir.
Okay. So yes, NEET guys, you all have got this book, right? Ashish Arora book.
Sir, I can't see a video.
You all have got the Ashish Arora book that I told you, 22
Sir.
years NEET paper. All the
Yes,
NEET
sir.
guys have got it. Yes. See page number 2. Page number 2. Okay. You have got 1.4 as vectors, right? 1.4, topic number 1.5. Can you
That's for
can you
JEE
all
or NEET, sir?
NEET, first NEET.
Okay.
Sir,
Can you all see? Did you all get, guys? Page number 2. For NEET, I'm talking about NEET first. You all have ordered, 22 years. Oh, you okay,
fine.
okay. I think, or 35 years you have ordered, right? For
Yeah.
NEET. Oh, okay. That's why the confusion, huh? Okay. Okay, guys, less than a
Sir.
minute. We'll come back again in 10 minutes and I'll tell you which questions you are supposed to do. All right, for NEET and JEE. So you tick mark them
Okay,
first
sir.
and then you're going to do it and then we continue. All right, so I'll see you in 10 minutes time.
Sir.
Cool, join.
So could you send the PDF version of the book, as I don't have the book yet?
I'll send it.
Okay,
Don't
yes, sir.
worry.
Thank you, sir.